morning all of you. So today we are going to start lecture number 8 from natural product 1. Then your next topic is general structural features and occurrence, biological importance and application part. Let us we have to see the first one, that is flavones. This flavones is a natural pigments. What is mean by natural pigments? It is naturally occurring coloring substance obtained in living organism. Okay, so let us see the structural features of flavones. In the structural features, first of all we have to draw the structure of flavones. How to draw the structure? First of all, it is bicyclic compound. The two ring is attached to this fused carbon containing one heterocyclic compound because the oxygen is present in the ring. Okay, then when we have to give number of this bicyclic compound, then number 1 is goes to the oxygen, then second, third and fourth, fifth, 6, 7, 8, 9 and 10. At second position, presence of one double bond, and at the fourth position, presence of C double bond O, and at the second position also have a one substituent, that is phenyl ring. Okay, so that is the structure of flavones. Then the next point is the molecular formula of flavones has found to be C15H10O2. Look at the structure and count how many carbon atom, hydrogen and oxygen. Okay, so one carbon number 2, that is also have a one carbon, then second carbon, third, fourth, fifth, 6, 7, 8, 9, then 10, 11, 12, 13, 14 and 15. So there are 15 carbon in the structure. Then next, hydrogen part, there are 10 hydrogen. Okay, so in our flavone structure there are 10 hydrogen. Okay, so on benzene ring, presence of one hydrogen, 1, 2, 3, 4, 5. Okay, and one hydrogen is replaced by this carbon, so total hydrogen in phenyl is 5. Then here at the third carbon in a bicyclic compound, presence of also one hydrogen, that is 6, 1. Then fifth position have also hydrogen, then 7, 8, 9, 10. Okay, so there are 10 hydrogen in flavone structure, and then there are 2 oxygen also. This one is in heterocyclic compound, presence of one oxygen, and this C double bond O indicate one oxygen. So there are total 2 oxygen, 10 hydrogen and carbon 15 in the structure of flavones. Then your next point is the number of hydroxyl group can be estimated by acetylation method. That means, suppose in the flavone structure presence of hydroxyl group, then you will get acylation, but absence of hydroxyl group in the flavones cannot do acylation process. Okay, remember this. When acylated flavines does not yield any acetyl derivative indicating absence of any OH group. Okay, so that is flavones in the flavone structure do not have a hydroxyl group, that means cannot do acetylation process on flavones. Okay, next one, when flavones fuse with KOH, it yields phenol and benzoic acid. We have to take first flavones. As we know the structure of flavones, it is fused with KOH. What is the name of KOH? Potassium hydroxide. Fusion of flavones and with KOH, then you will get two product, that is phenol and benzoic acid. Next point is when it is boiled with alcoholic KOH. What is it? Alcoholic KOH solution. It gives mixture of 4 compounds. Let us see in the reaction form. C15H10O2. This formula indicate it is a flavones. These flavones when boiled with alcoholic KOH. Alcoholic KOH means what? When we have to take KOH and in that we have to add polar solvent, polar organic solvent into it, polar organic solvent into it, and formation of K plus and OH minus ion. So when we have to add alcoholic KOH into flavones in the presence of heat or it get boiled, then you will get mixture of 4 compounds. So first compound is salicylic acid. As we know the salicylic acid structure, the presence of one COH group and then second position have a hydroxyl group, so that is salicylic acid. This is common name. What is the IUPAC name of this salicylic acid? 2-hydroxy, what is it? 2-hydroxy benzoic acid, benzoic acid. Okay, then your next compound is acetophenone. What is the acetophenone structure? Benzene ring is attached to C double bond O CH3, so that is second compound, and the remaining 2 compound is O-hydroxy acetophenone. That means this is para position and this is ortho position. So ortho position have a hydroxy group and main molecule is acetophenone. This is what? Acetophenone. Okay, so third compound is O-hydroxy, that means ortho hydroxy acetophenone. Then next is benzoic acid. What is the benzoic acid? Benzene ring is attached to COH group, so that is benzoic acid. That means your flavones, it get boiled with alcoholic KOH, then you will get salicylic acid, first one, then second one is acetophenone, then third one is O-hydroxy acetophenone, and fourth one is benzoic acid. Remember this. Then next part is occurrence of flavones. Occurrence of flavones, that means you can also say it is sources. Which source is here? First one is flavones are also known as anthraxanthine. Anthraxanthine. Okay, this is another name of flavones. Remember this. It represent important group of yellow pigment. I already tell you flavones is the pigments. And what is mean by pigment? It is coloring substance obtained from living organism. So flavones color is yellow that occur in a plant. Okay. Then second one is they occur either in a free state or as glycosides, a combination with glucose and rambos. Okay, free state means what? It is naturally obtaining, or as glycoside means what? It is containing glucose and rhamnose. Then next occurrence is it occurs as dust on flowers and leaves and seeds. That means in the dust form you will get flavones on flowers, leaves on tree and seeds. Remember this. Then your next point is biological importance of flavones. First biological importance is responsible for flower coloration. That means when flowers present in the any flower, then the flower get color. Okay. Then next point is involved in UV filtration, ultraviolet ray filtration. Then involved in also nitrogen fixation. What is mean by nitrogen fixation? When nitrogen and hydrogen gas will comes together, then formation of ammonia molecule, that is nitrogen fixation in the presence of nitrogenous catalyst, that is biological catalyst. Okay. Then next one is also act as chemical messenger. What is it? Chemical messenger. The role of flavones is chemical messenger. Then another one is physiological regulators and cell cycle inhibitors. That is also biological importance. Then the last part of flavones is application of flavones. First application of flavones is methoxylated flavones are natural antioxidant. As we know, the antioxidant, turmeric is also antioxidant. Like this, the methoxylated, that means when flavones on methoxylation, then that flavones are natural on antioxidant and might reduce inflammation. Okay, reduce inflammation, that means pain release in our body, that is inflammation part. Then next application is they might also affect the way liver processes. It is good working against liver and cholesterol and other blood fats. Then last one is scientist thinks methoxylated flavones might also reduce spread of cancer cell. Scientist thinks, that means your flavones part, methoxylated flavones part is treatments again to control the spread of cancer cell. So that is your flavones part. Then our next part is synthesis of ubiquinone from 3,4-trimethoxyacetophenone. This is your reactant part in synthesis of ubiquinone. Okay, so let us see the step 1, preparation of 2,3-dimethoxy 5-methyl hydroquinone. First of all, we have to prepare in the step 1 2,3-dimethoxy 5-methyl hydroquinone. So let us see how it is formed. First, we have to take main reactant, that is 3,4,5 trimethoxyacetophenone. Let us see. First, we have to remember what is your acetophenone part. Benzene ring is attached to C double bond O CH3, that is your acetophenone part. Okay, and what is your next remaining substituent? This is position number 1, then second, third, fourth and fifth. 3, 4, 5 position have a methoxy groups, that means 3 methoxy group indicate trimethoxy. So that is your main reactant to form ubiquinone product. This reactant undergoes selective reduction. What is meant by selective reduction? A removal of oxygen molecule and add hydrogen molecule. Okay, then what is the change in the next step or next part? That is, after selective reduction, your C double bond O CH3 is converted into CH3 after selective reduction. Then this molecule name is 1, 2, 3, 4, 5, 6. 3, 4, 5 trimethoxy. 3, 4, 5 trimethoxytoluene. This 3, 4, 5 trimethoxytoluene is diazotized with next reagent, and you will get the next molecule after removal of HCl. This ended HCl and second position hydrogen is removed, that means removal of HCl in the presence of 0 to 4 degrees Celsius. As we know, diazotization process is in the presence of 0 to 4 degrees Celsius, and you will get after diazotization the carbon atom. After removal of HCl, your carbon is bonded with this nitrogen in diazotization process, and nitrogen is again double bonded with nitrogen, and the cyclic ring, cyclohexane ring, and at the para position have a NO2 group, nitro group. After the diazotization process, why it is diazotization? Because the nitrogen double bond nitrogen indicate diazo group. In the heterocyclic compound, nitrogen is called as aza. So here it is 2 times present, so that's why it is called as diaza group. After diazotization, catalytic reduction take place. After catalytic reduction means what? In the presence of catalyst, addition of hydrogen between across the n double bond n, that means 2 times when add the hydrogen across the double bonded nitrogen, then you will get here the nitrogen molecule is attached to 2 hydrogen and it converted NH2, and this cyclic ring containing nitro group and this NH2 group convert the byproduct. You will get byproduct in this reaction. After that, oxidation take place of this reactant molecule, then you will get first step product, that is 2,3-dimethoxy 5-methyl hydroquinone. What is the structure of this hydroquinone? This is position number 1, second, third, fourth, fifth, and this is position number 1, 2, 3, 4, 5th and 6. 2, 3 dimethoxy. Second and third position have a methoxy group. Then 1 and 4th position have a C double bond O group, that is hydroquinone part, and 5th position have a CH3 group. That means your NH2 molecule and OMe, that is methoxy group, is converted into C double bond O. So that is your step 1 product. Okay, so then your next step is, this is last step of ubiquinone synthesis. Condensation reaction between trans-allylic alcohol gives final product, that is ubiquinone. So this is last step of ubiquinone synthesis. When we have to take step 1 product, this is what? Step 1 product. At position 1 and 4 C double bond O, then second and third position have a methoxy group, and 5th position have a CH3 group. That means 2, 3 dimethoxy 5-methyl hydroquinone is reacts with allylic alcohol. This is what? Allylic alcohol. This position indicate allylic position. Okay, and remaining presence of hydrogen, that is bond line formula. So this allylic alcohol, trans-allylic alcohol, is reacts with step 1 product. Then you will get ubiquinone in the presence of mercurous chloride or silver nitrate, in the presence and removal of water molecule. How to remove water molecule? At position 6, the position 6 have a 1 hydrogen, that means your hydrogen molecule and OH molecule is removed. That means water part it get eliminated in this reaction, and you will get the carbon is attached to this carbon of allylic carbon. Okay, then you will get ubiquinone. So that is synthesis of ubiquinone. Okay, thank you.